Good day guys, today I'll be doing analytical geometry for grade 11 and 12. Similarly, also grade 10s can also watch the video. So dealing with the analytical geometry, we are basically dealing with formulas. It's about formulas and following formulas and your skill to utilize those formulas in difficult situations. They will be asking some difficult questions with those formulas, but basically analytical geometry is all about using formulas, nothing else. Okay, let's get into it. So you'll be given a distance, 2 points, whereby you need to find the distance between 2 points. Simple formula, you just need to memorize square root of the 2. You are utilizing the coordinates of xb, for example, then minus xa squared plus yb ya. What you started with this side, to start also with this side. The gradient of a line, very simple. You utilize the same thing, utilize the coordinate. The midpoint is basically the middle of the 2 points. We go to the inclination of a line. Basically deals with the angle that is across the x-axis. For example, here I have the y-axis and the x-axis. The inclination is always on the x-axis. It is across the x-axis, always on the x-axis. If it does not touch the x-axis, it's not an inclination. The formula is very simple, straight to the point. It's the tan theta of what? Is the tan theta of the gradient. Is the tan theta of the gradient of that line. We go to the parallel lines that have inclinations. Basically, we know that the gradient, if you have parallel lines, for example, you have parallel lines. The gradient of this line is equal to the gradient of this line, straight to the point. Then we have the perpendicular lines with inclinations. If you have perpendicular lines, for you to check if they are perpendicular lines, we need to check if the gradient of this line multiplied by the gradient of this line will give you a -1. Then you know that it's a perpendicular line. They are perpendicular lines. Equation of a line. There are two formulas you can use. I think there's a third one, but then I wrote these two. Very simple. Very simple. You have a gradient. You have a c is the y-intercept. Then straight to the point. Here you have the gradient and the coordinates. Straight to the point. Then I'll be moving